Alright, how we doing, ladies and gentlemen? Welcome to another edition of Math with Mr. Stevens. Today we're going to be on page 159, still in lesson 15, still looking at these different pairs of lines that have been placed on coordinate planes. And so today, this one with pair 4 is a little bit different than the ones that we have seen thus far. Alright, and we're going to see why here in just a hot second. Essentially, part A asks us which graph is steeper. And that's been our question. That's been the first question. That's been really our look at determining between the two lines that have been given to us, the two equations that have been placed on these coordinate planes, which one is steeper, and as a result being able to determine which one has the larger slope. With graphs A and B, though, these are quite a bit more difficult than the previous examples that we've had. The ones we've had before, we could look very clearly and see, oh, that one's clearly steeper. Alright, so graph A and B, though, these ones are quite a bit closer in terms of which one is more steep. They both seem to move at a fairly similar angle. Alright, they're both moving in the same direction, they're both moving at a similar angle, and so really what it's going to boil down to is determining what the actual slope is and figuring out which one is indeed steeper. So, for right now, we're going to just put, it's unclear which one is steeper. Until we actually determine the difference and the actual directional difference between the two sets and between the two lines and the sets of points on each line, it's going to be difficult to discern. So, let's take a look at graph A and the 2 points that are located on graph A. So graph A, we have a point at -2, -2. Fantastic, and we also have a point at 2, 2. Alright? And so to get from -2 to +2, +2, we'd have to go up 1, 2, 3, 4. And we go to the right, 1, 2, 3, 4. Okay? So we're moving up, again, that's a positive movement, and we're moving right, again, that's a positive movement. So both of these movements are positive, +4 and +4. So for graph A, our directions are up 4, right 4. Okay? Now let's take a look at graph B. Graph B has got a similar set of just 2 points on the line, very similar to what we had before. Our coordinates for this point are 1, -2. And for this one is 4, 1. And so again, we're going to do the exact same thing. We're just going to count. We're going to go up 1, 2, 3. So it's an increase of 3 plus 3. And then we're going to go 1, 2, 3 to the right. So that's also an increase of 3. So for graph B, our directions are up 3, right 3. And so we're taking a look at a pair of equations that we have yet to see. In particular, these two equations have very similar directional patterns to get from one point to the next. Here we're going up the same amount, up, and to the right the same amount. The same thing is also true of graph B. Though we're looking at two different actual distances, two different sets of points that we are going from one to the other, and they're obviously in different locations. This one is crossing the y-axis at -3. This one's crossing the y-axis at 0 in the origin. They're in a different location. But the way we get from one point to the next is quite similar. If you take a look at some of the other points that are located on these points, if you go from one to the next, you'll see that all of these actually meet at whole values. All of these actually meet at whole numbers. There is no crossing at kind of a weird spot. The same thing is true here. A lot of the problems that we've had so far with other slopes, they've crossed at a line that, or at a vertical or at a horizontal line point that doesn't give us a whole value. In this particular case, both of these, at each point where they cross, as the x increases or decreases, y increases and decreases by a whole value amount. And so when we come to part C, and it's time for us to put this together as a slope, for graph A, we put together our slope the same way we've been doing. The vertical change, which is a +4, divided by the horizontal change, which is also a +4. So +4 divided by +4, 4 divided by 4, that gives us a slope of 1. We're just going to reduce that down to 1. Okay? So this is going to be our slope. Slope of 1. Easy. Essentially what that means is, as x increases by 1, y also increases by 1. These are going to be moving at the same amount. So if we go from 0, 0 here, then we move from 1, then y goes to 1. We go to 2, we move x to 2, and y goes to 2. We move x to 5, and y is going to go to 5. So all those increases, it's a 1-to-1 change. As x increases by a value of 1 or a factor of 1, so does y. Let's check graph B. Sorry, always looking up to make sure you can see everything on the screen. Graph B. Same thing. We're going to put our change in y and divide that by our change in x. Okay? So our increase of y, our increase of our vertical change is a +3. We went up 3. And then our increase in horizontal change, or our change in horizontal movement, was an increase of 3, moving 3 to the right. So 3 divided by 3 is a what? It's also 1. So for both of these lines actually have the exact same slope. They have the same level of steepness. So when it comes time to ask which graph is steeper, the answer is essentially neither. They are the same. They are the same steepness. Okay. So this is something we can and probably will come across again here in the future, is looking at two different equations given to us, or potentially an equation and a graph, and we have to be able to determine which one is steeper, even though they're in different mediums, even though they're in different representations. So the quick and easy way to do that is by just comparing the slopes. So here we're looking at the slope in terms of its physical representation. Very soon we're going to be looking at slopes in other ways. So this is it for this one. We're just doing pair 4 here. We're moving on. We've got a couple of more that we're going to continue to go through and pushing on and pushing through lesson 15. Adios.